Are you concerned about bacteria contamination in a water source that is a major health problem, or that causes women to walk long distances to get clean water? If you are, I want to tell you about a new Australian development called Rota Pota that might solve the problem. The Rota Pota shown carried by Alan of Men's Shed is a hand-operated microfiltration system using the Xena 0.1 micron hollow fibre membrane. Clean water passes easily through this type of membrane, but bacteria and visible solids cannot. Xena and other makers have proven over many years that water passing through this size membrane will be virtually free of E. coli bacteria. Rota Pota is designed to use this proven membrane in a system that can operate on many different types of raw water with minimal pre-screening, can maintain output quality without a skilled operator, is hand-operated, needs no electricity, needs no installation work, and is easily portable for short or long-term operation, can be maintained with minimal resources, and is economical to produce through design and by construction in men's shed around Australia. Rota Pota should filter 30 to 60 litres per hour depending on the raw water. This makes Rota Pota suitable for schools, health centres or small compact villages. Rota Pota can filter water that has a high solids content because it has backflush and air agitation, can handle high concentrations of clay or of algae. Rota Pota has 4 bundles. Inside the raw water tank, 4 Xena membrane bundles connected to a common manifold are enclosed in an open 100 mm pipe. A 15 mm pipe from the air pump enters the bottom of the 100 mm pipe. Each Xena bundle has 1400 polypropylene hollow fibres, nominal pore size 0.1 microns, total surface area about 1 square metre. Fibre size 310 microns outside diameter, 240 microns inside diameter. Typical log removal rate for fecal coliforms is 5, with higher rates for larger microorganisms. Backflush system clears pores. Air agitation prevents retained solids from concentrating within the bundle. On the left, the valves are set so the hand pump is drawing water from the raw water tank into the hollow membranes and pumping into the discharge pipe. On the right, clear water is drawn from the discharge pipe and pumped through the hollow centres of the fibres out through the fibre walls to flush fine solids from the pores. Backflushing frees solids from membrane pores but does not disperse these solids. The diaphragm pump supplies air that causes a strong current of air, bubbles and water past the fibres to sweep away the loosened solids. Raw water flows to the membrane fibres where clean water is withdrawn, leaving solids particles behind. Air bubbles in the 100 mm enclosing tube create an up current around the membrane fibres and a down current in the rest of the raw water tank. This makes sure that dirt particles are distributed throughout the raw water rather than all accumulating within the bundles of fibres. The concentration of dirt particles in the raw water tank will increase to a practical limit, at which time some concentrated raw water must be dumped to waste. Limitations. Microfiltration is a barrier to visible solids and to bacteria. Microfiltration may reduce virus concentration because of attachment of virus to solid particles. However, unlike bacteria, the size of virus is smaller than the pore size of the membrane. If water is contaminated with virus, additional disinfection may be desirable. Microfiltration is not a barrier to dissolved solids such as salt and other dissolved chemicals.